We have covered the basics of vectors in the lecture for tensor, and within this lecture we are going to cover vectors topic in more details. So far we have understood that vectors are a one-dimensional array that may look something like this. So a vector A can look like this, and elements of a vector can be accessed by its index. So let's say I want to select this element of the vector, then I can call it as A2 like this. If you're coming from a Python background, then you must know that the indexing in Python starts from 0, and in that case you will have to call that index in this way. So if you're calling the second element, then you will have to call it like this as 1, because the indexing starts from 0. And within this point we will try to understand that how vectors represent a point in a given space. So the length of 2 represents a location in 2D surface. So we can see this example right here. So we have this vector with elements 4 and 2, which is representing a point in a two-dimensional space that we have here, x-axis and y-axis. And within this two-dimensional space, this vector right here is representing a certain point. Similarly, a vector of length 3 will represent a location in 3D cube. Like we have this 3D cube here on the screen, and if we talk about this particular point, then of course this has some length in the x-axis right here. It also has some length in the y-axis right here. On top of that, it also has a height. So the z-axis is also there. And this is how a vector with length 3, that could be something like this. Let's say that we have and 5. This will be an example of a vector with 3 dimension that will represent a location in a 3-dimensional space. And finally, the vector of length n will represent a location in n-dimensional tensor. So the number of dimension can go up to n. However, humanly it will be possible to visualize a vector only up to 3 dimensions. But as we have discussed earlier, that computers are very good at handling and doing multiple calculations with a tensor or vector of n dimension. Okay, so we have covered the topic of vectors. Now let's move on to the topic of vector transposition. As you can see, we have a vector A which has 3 elements, and the shape will be 1 and 3 because this vector has 1 row and 3 different columns. And if we will have to calculate the transposition for this vector, then it will be transformed like this. So A transposition will look something like this. The row will become the column, and the shape will change from 1, 3 to 3, 1, because now we have 3 different rows and only 1 column right here. And this is how we can transpose a vector of any given dimension. To understand it better, that how this calculation works in machine learning, we also have a coding demonstration. Okay, and before we get started with this part of the lecture, if you are someone who is coming from a non-coding background or someone who has no prior understanding in machine learning, then you can feel free to skip this part. However, I would suggest that you watch till end, because we are not going to cover any rocket science over here. It is a pretty basic thing, and it will come very handy once you start your journey with Python learning or the concepts of machine learning. So I am using Jupyter Notebook over here for the demonstration purpose, and I am importing 2 different libraries. First is NumPy and second is Matplotlib. Although we are not using Matplotlib within this lecture, so I can also skip it for now. So let's import NumPy as n, and I am using this method np.array in order to create this one-dimensional vector, or you can say array in Python, and I am assigning this to x. And after assigning this to x, I am also checking the value for it. So if I will run this cell, then as you can see, I have a one-dimensional array with 3 elements inside it. If you want to check the length of x, then you can run this piece of code. It will help you checking the length, and we have a length of 3. And as we discussed earlier, that if you want to access a specific element from the array, let's say that you want to access the third element, then as we know that indexing starts from 0 in Python. So it will be 0, 1 and 2. So I can use x bracket 2 in order to call the third element of the array. And now let's check the shape of this vector. So I will run this cell, and it says 3, nothing. Now you must be thinking that since this vector has only 1 row and 3 columns, the shape should have come as 1, 3. but we are getting 3 comma nothing. Why is that? It is because that the vector we have right here, it is a one dimensional vector with 3 elements. It is one dimension because we are using one single bracket right here. So we will have to make it a 2-dimension vector by adding 2 brackets both the sides. So in the very next cell, I am going to reassign the value of x by making the vector a 2-dimensional vector. So I will simply run this cell, and if I will check the shape again, then you will see that we will have an expected output which is 1 comma 3. And now I am going to take the transpose of this vector x. So x dot t will provide us the transpose, and I am going to assign that value x underscore t variable. And then if we check the variable value, then we will get this. So the row has been converted into columns. Also, if you want to check the shape of this x transpose t, it will be reversed into 3 comma 1. And before we finish, let's quickly see that how to calculate the dot product between two vectors. So I have taken these two vectors here, which is vector x and vector y. And remember that you can calculate the dot product between two vectors only if the number of elements or the length of the vector is same. As we can see, the vector x has 3 elements and vector y as well has 3 elements. Only in that case, the calculation of the dot product between two different vectors is possible. So let's try to understand with this simple example that how are we calculating the dot product between two different vectors. So we are multiplying the first element of vector x with the first element of vector y. Similarly, the second element of vector x is being multiplied by the second element of vector y. The third element of vector x is multiplied by the third element of vector y. And then we need to sum up all the values in this calculation. So 4 multiplied by 1 is 4, 5 multiplied by 2 is 10, and 6 multiplied by 3 is 18. We just need to sum it up and we will get 32. So 32 will be the dot product between these two vectors, vector x and vector y. And now let's move on to the Jupyter Notebook, and we will see that how to do the same calculation by using Python. So I'm using the NumPy library to create these two vectors, vector x and vector y, and I have kept the same set of elements for both the vectors so that we can have the same output as a dot product. So let me just execute this cell, and if we check the value of vector x, we get this array, and if we check the value of y, we get this array. And you can use this syntax in order to calculate the dot product between two arrays or two vectors, and if we do it, we get 32 as we were getting by manual calculation. Okay, that is it for this lecture. I hope that you were able to understand the concept of vectors, how can we access elements, how a vector with 2 dimension or 3 dimension represents a point in space, and also what is vector transpose. Hence, please stick to the playlist and subscribe the channel if already not subscribed, and drop a like below to support our work. Thank you very much for your time today. See you in the next lecture.